those who were asking about this question, model physics, you remove specimen paper. This question is from we're in 2026. 2026, paper 3, specimen. Right. So the first question was part of Takaita. Millikan's drop experiment states the photon energy equation. So we all know that the energy of a photon is equal to HF, right? Every time you are not stating an equation, you must give us the meaning of the terms. So we are going to say where E is what? Is the energy in joules. H, this is called the Planck's constant. And the F, this is the frequency. So actually from this equation here, we can see that energy in a frequency is very directly proportional. If you look at because sometimes you can choice a question graph, right? Energy and frequency. Then you must know that these are directly proportional. So the straight line that passes through the origin. However, formula if you're going to ignore as E is equal to hc over lambda, where c is the speed of light in vacuum and lambda is the wavelength. So I'm going to kushamisi kama hivyo kutusaka zava kupi tunenge zava hapa pakutitezwa kuti c is equal to f lambda, right? So if you make f subject of the formula, here you can see that frequency is equal to c over lambda. So if you take this value, you substitute r in place of frequency, then this expression. Okay, so this is the formula that we use to calculate the energy of a single photon. So this formula is for calculating energy of a photon. E is equal to HF and E is equal to HC over lambda. So in that case, man, can I draw a graph? Maybe E versus lambda. E versus lambda. It will be like this. We have energy in the vertical axis, and then we have lambda. So the graph of actually these two are inversely proportional. As you can see, we said E is equal to HC over lambda. Definitely the denominator cannot be 0. So these two will be inversely proportional like this. But if it touches here, it means that the denominator is 0. So they're inversely proportional. But you must also be careful, because you can have a graph of E, but horizontal axis match, negative 1 over lambda. So E in 1 over lambda is very directly proportional. Just na E versus lambda. Okay, let us proceed to the next question. So the diagram here, it shows a vacuum photocell with incident light of wavelength 600 nanometers. So light is regards incident light. This is the light that is propagating towards what your photocathode, right? So this photocathode is just a what? This is just a metal. So light is way up. Light here, we are being told that the wavelength of this light is 600 nanometers. I hope you know the meaning of this prefix, right? It's directed at the photocell and the ammeter reading is 0.5 microamps. So we are also given the current. The ammeter here, it measures current. So current that is flowing in a circuit here is 0.15 microamps, which is 10 to the power minus 6. So I assume that basically you know what is happening by now. According to the photoelectric theory phenomenon, we understand that light is negative way banana. Semunhu we-physics awufana ukuona light as just something very ordinary. Light rine ma-particles are now, right? These particles dzinowanikwa mulight ndo atinoti machi ma-photons, right? Each photon ndo ine energy that is inokalkulate neformula dzipi, formula zedu dziri dzataura. So each and every photon is nowhere. When you are looking at it, you must see it as energy that is coming, but the energy is in form of packets, right? While it's the energy in each packet, that's the energy of a photon. So, my photons we know that metals with electrons. So photon but not surface metal, not energy, electron, and then we are going to have electrons being what? Ejected from the metal surface, and then the electrons are going to complete the circuit. So basically this is how this system operates. So our first question is calculate the energy of incident electromagnetic radiation. In no incident electromagnetic radiation, you are supposed to calculate the energy. So that this formula of energy, E is equal to Hc over lambda, or E is equal to Hf. So it is much easier and direct to use this one. What is the value for H? 6.63 times 10 to the power negative 34. This is Planck's constant. We want to data sheet at percent paper. And then 3, that's the speed of light, times 10 to the power of 8. Or of what? The wavelength in power, which is 600 times 10 to the power minus 9. Let us punch our calculator and we are going to know the energy, right? So I'm getting 3.32 times 10 to the power of minus 19. Your energy here, one photon, right? So the photon is going to one the energy. I'm going to say ndo siya pa surface pe metal. Energy yo store on electron. Then electron move. Then calculate the number of electrons emitted per second. Number of electrons emitted per second. So here, time is equal to 1 second. Time may do out of walk down. So we are going to say we also know the current. So we are going to say Q is equal to IT. In doing so, we are trying to calculate the charge. The charge in the flow circuit reduced. So current is 0.15 times 10 to the power of minus 6. Time was going to 1 second. So obviously here I'm going to get 0.15 times 10 to the power minus 6 coulombs. No charge. This charge each charge no flow on second per second. So what you want to know is the charge is associated to how many electrons. So which formula relates the charge and the number of electrons? Q is equal to Ne, right? Then you use that expression. Q is not charge, N is not number of electrons, E is not charge by electron and another one. So let's substitute. Charge written now is 0.15 times 10 to the power of minus 6. Then to divide and charge electron and another one. We will decide N. So charge electron and another one is 1.6 times 10 to the power of minus 19. This is the magnitude. So any addition but one ani kana taka by redu ma calculators redu. So here we are going to get 9.375 times 10 to the power of 11 electrons. Right.